Okay. Hello, Louis.
Louis, I have sent you our application works in OpenBSD in 5 architectures.
Five
Uh,
architectures.
yes,
Ah, the
it's IRM,
yeah,
MIPS, AMD
you
AMD
you have
64X 386 and other stuff. I sent you in direct
yeah, I saw that. Saw that.
message.
So you have access to a PowerPC 64?
Yes.
Oh, you
No,
do?
no. Actually, when you compile on the Golang, it automatically compiles for
It doesn't
different
matter.
architectures. It's a cross compilation feature of the open Golang.
Oh, I see. I didn't realize that. That's too funny.
Yes, it's
Yeah,
very. I always compile for all versions of
yeah,
OpenBSD. I have a lot of small software which is like uh, command line tools which could be used on OpenBSD.
yeah. Okay. Because I have actually I do have a PowerPC somewhere. I
Mhm.
have an old
You can
MacBook.
check. Maybe some databases will not work because
Yeah,
some of them are not tested on other platforms.
yeah,
But you can check. Maybe SQLite will be working, or some. We
yeah,
have different databases. Some of them may be working, maybe not. We can't check.
yeah.
Maybe
Well,
only you can check.
Risk V64 isn't that a Raspberry Pi?
No, no.
No,
Raspberry
no.
Pi is ARM.
Mm.
ARM.
ARM. Oh, sorry. Right. Risk 5. Yes, 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 yes.
RISC-V is some old stuff. I
Yeah,
do
yeah,
not
yeah.
know.
That it's the open source. It's the open source architecture. Yes, yes. Mm.
Yes, yes. It was interesting processor, but it has gone, I believe,
No, it's
or
around.
maybe not.
Risk 5. Yeah, yeah.
Mm,
It's quite popular.
mm.
So anyway,
Hi, Michael. Sorry, I saw Michael coming up. It's still dark, but Michael
This is the
showed up.
benefit for using Golang that you can compile for different platforms simultaneously.
okay.
If you, but for doing that, you should always um, proceed with the Golang, how to say, proverbs or how to say, philosophy. You should never use external libraries.
Yeah.
You should always go with the vanilla code and vanilla libraries and basic stuff like if you use uh, SQL, you should use straight SQL. You should not use dialects or some other libraries. You should always try vanilla, and after that, it will compile for all the
Yeah.
databases.
Okay.
So
Interesting.
if you need uh, some features that are available in different, for example, databases, you should incorporate it inside your code. This in this case, it will be compatible even with the how to say phones or even the microcontrollers. You see, Golang can be compiled directly to the binary from firmware.
Mhm.
Interesting.
Mhm.
No.
Very good,
Mhm.
and it will be for absolutely different architectures like Atmega, Harvard architecture, and RM architecture. They are different libraries, but you do not use these libraries. You write the straight uh,
You
machine library called.
incorporate it into your source code. Yeah.
Mhm.
Ah,
So you can change processors on the fly.
okay. I'm not
Instead of Arduino, when you need to rewrite the code.
Yes, yes.
Sure.
Absolutely.
Interesting.
Hmm.
The okay, well, I'll give it a try. 'Cause I do have an open BSD server out there. It's in a data center. in British Columbia, but I'll give it a try.
OpenBSD is good. I went to check
Oh, yeah.
Linux Mint and found the OpenBSD installation on my computer, so I tried.
Oh, yeah.
That's
Yeah.
why.
Well, yeah, no, OpenBSD is not really for the desktop.
Yes, it's a network router.
It's a server. It's a server, yeah, edge
It's
server.
on the server, yes.
Mm.
But very good network server.
So Louis, I saw that you did a lot of work on the how do you call them, on the calculations. So you want
Yeah,
to talk about that? You want to share
sure.
your ideas or your findings?
Yeah. Actually, I have an experiment running right now. I started it yesterday morning and then forgot about it. So it's been running at roughly 1100 CPM, so a very high count. So right now my Zen is clocking 3.2 microsieverts per hour, which is quite large. So and I haven't had a chance to analyze that data, but I can let's say, let me share this window right now. Share. Hello. There we go. Quite slow. Yeah, desktop number 2. There we go. Sure. There we go. So you should see the spreadsheet. Yes?
Yeah. Yeah.
Okay,
we
good.
can see.
Yes, we see it.
So so right now, let me just zoom in a little bit. So what I have here is this is the raw data that's coming from the raw data that's coming from the Arduino. Basically, just running on a tiny little 32-bit Adafruit. So that's the millis. So right now, it's just been running continuously. So basically it's just telling you that it's every 60,000 milliseconds, or in other words, every minute. This is the actual count. So nominally it's 20, like I kind of set it to be roughly 30, but it actually turns out to be 27. And then I do a little bit of statistics here. Come on. I'm not a big fan of LibreOffice. It's just a little bit clunky. I hate to admit that Microsoft has actually a really good product with the whole Office.
You should try only Office. That's quite good.
Only Office. Okay, I'll try.
Yes. That's also free for desktops.
Okay, so the average turns out to be 27.5, and minimum 12, maximum 44, which is fine. And the standard deviation of this column here is 5.2. You notice if it's a normal or Poisson distribution, the standard deviation should be about roughly, it should be the square root of the average. And so we have the calculated standard deviation, and then I take the square root of the average here, and we're seeing that it's
quite close. Yeah.
It's quite close. And then if we go back and have a look at the picture, it's very satisfying. There we go. So that's the basically 1,000 or 1,100 samples. So it's starting to, definitely starting to look. And if I let it run, it would probably look even closer. So here's your 27 here, the 20. This is the 27 bin.
Yeah, something like that.
Yeah. So anyway, so right now I've got the 1100. It's been cooking for quite a long time. I'm just going to leave it, and we'll have a look at it after the meeting. Taking your suggestion, or okay. So right now I am doing. If I go look at the source code, where's my source code here? Pulse maker. So um, like Matvey was saying, if you include the library as your source code, and that's exactly what I did with this implementation of the Mersenne twister. So I didn't really want to play with it. I didn't want to turn it into an Arduino library. I just sort of took the C and H files and the parameters
Exactly.
and just introduced them directly. So where's my, that's the source. There's my main. So right now you can see that I'm doing the repetition timer is looking at strictly at the millis. It's soft real time. It's not hard real time. And that repetition timer is 10 milliseconds. So to make it more free. So what I want to do with this experiment is, first of all, have something that's realistic that we can apply to any device to test the summation algorithm. In other words, the part of the software that gives you counts per minute, right? So whether it's the one bin, like the 60 bins in a minute, and then you sum those, or if you actually record 60 seconds, call it and then output that summation, like that, the amount in that 60 seconds, and then you restart, output the next 60 seconds. So it gives you, obviously it gives you a 1 minute lag, which may not be good, but it'll give you accurate. So we can test those algorithms. On the flip side, what I really want to do is generate the pulses as if it was the sensor. In other words, have a high voltage transistor like
Yes.
like SIGFET or something like that, and just
Pull
at
it
the
down.
pulse time actually pulse, right?
Uh-huh.
And that would allow us to test devices like the Safe Pulse or the iRover to figure out what the actual dead time is.
You have to make the dead time on it, so it goes down, and then you have to with maybe a cap or something to
Yeah.
get the curve
Yes.
correctly. Yes.
Yes. Yeah. So to reproduce that, so that we can test devices like the Safe Pulse and iRover and whatever else we want to try. In other words, pretend it's the tube, and that way, and that becomes a kind of a general purpose tester. And I'm not going to run it. Eventually, I'm not going to run it on the Arduino because it's so much easier to run it on an M5 stack, like a Core 2 or something like that. Because now you have the GUI and you make it into a test instrument.
Yeah.
So.
No, I think that's a good idea. I had a similar idea about a year ago to do it like that, to build it, but I never made it. So it would be great if you could do that.
Yeah,
that would really help.
Yeah, I'm open to ideas. I've got some.
You need a good FET.
Yes. Well, it's probably going to be silicon carbide.
Yeah, silicon carbide and fast.
Yes, yes. So that's going to be a matter.
Probably a wool version. I have many different versions. I can send you the one of the good ones. And if you want, I can send them. I have a few here.
Yeah, that's okay. I can get it from DigiKey. That's not a problem.
They're not cheap. They're not cheap.
I know. The premium device, but I only need a few. So the other thing that could use is high voltage SCR. You just fire the SCR. Anyway, so I'll play with that. I'll have to get a high voltage probe for my scope.
Yeah, that's important.
Anyway, so the next step here in my little test bed here is to check out the time of arrival, right? Between pulses. right, to make sure that it does have that exponential distribution. So we'll see how it goes.
Okay.
So anyway, that's me for this week. Been kind of having fun. It's nice.
Yes, I saw the progress. That's nice to see that, what you're doing.
Yeah. So anyway, just going to stop sharing and get back to what you guys.
Okay.
Michael's here, isn't he?
Yes,
Michael.
Michael was there a while already, but I'm not sure if he's active or not. But...
Yeah, I'm going to mute my microphone because nobody needs to hear me slurping tea.
And sorry, Lewis, and you are creating a test device that will produce some kind of like radiation, yes?
Yeah,
like
a pulse. Just a pulse maker.
Pulses, yes. It will be just volts, yes. No, electric pulses, yes.
So right now, so I've got the processor that we use for the Zen, the M5 Core 2. This is basically, it's my Zen, my fake Zen. It's got processor, it's got the GPS. There's actually two different GPSs here. I don't know if you can
understood.
Focus. Anyway, and then here is just a little Arduino, and that's running the code right now. So it's basically a random pseudo-random generator, and whenever the value goes below a certain threshold, it fires. Right, and and it does that 100 times per second, so 10 millisecond interval. So and so it's a random process that tries to simulate the random process in a sample of material where you have becquerels per per liter or whatever. So so we're going to use that basically to simulate a real source, right? Right, without using radiation, because right now 1100 counts per minute. This is my house. I don't like having stuff like.
But no, if you have alpha on your desk, it's fine. It
doesn't
go so far.
I don't believe this.
No, I think my wife would.
I measured it. I got a source from Peter, and I got 600 milliseconds, millisieverts.
Yeah,
way up.
So Michael,
very good.
Michael, the two GPS units there are there's a BE and a BN. No, sorry, yeah. And they're just only one's connected right now. It's just that made it easier to switch from one to the other when we were playing around with GPS values. And because it's the double-sided sticky tape, it's just not worth removing it. So it's only one at a time.
Yeah, that's a good idea.
Very good. I also like I like testing without contamination.
Yeah, exactly.
Yeah, that's the best.
Now, the other project I want to, and I talked about that before, and I think Rob was mentioning that setup that Peter had with the pipes full of
no,
radio.
Joe had it.
Joe, okay, so I obviously don't have any sand from Fukushima, which is fine. But I'm thinking of now. I'm not. Maybe I want to talk to Joe about this or Kalin, because do I make it into a cube with 6 slabs, right, and then put the device inside, or one big wide slab and put the device face down?
So the way they made it, it was really a box, 1 meter, 1 meter box. I
Right.
can show. I think I can find pictures of it. Maybe then you have a good idea how it looks like.
Yeah. Well, I can't. I'm not sure I want a 1 meter box of granite. That'd be quite
No,
heavy.
that's true. No. I mean, they only make the pipes. So if you have some, the pipes around it makes it enough, maybe. But granite maybe not strong enough for that.
Yeah, that's what I was thinking of. Like basically one big slab, put it on top, and I don't know.
But you ideally you want to have some all directions.
Yeah, that's going to be difficult.
Ideally, it's a globe.
Right. So that's it.
The cube is already better, but if you have a globe around it, then it's really
Yeah.
the best.
Okay. Well, maybe I'll just contact Joe and Kellen and try out my idea. Because I mean, practically, I don't want a like a 1 meter slab on each side. I mean, that thing is going to weigh several tons.
True.
And what do you want to do? I did not get the with this slab is this cube. What will it be used for?
Basically, to create a chamber where the field, right, the radiation field is even throughout. In other words, it's like
not directional anymore.
Not directional, and strong enough field to knock out the background radiation from around it, so that we can now test the sensors themselves without, right, independent of the background radiation, and in a uniform field.
And don't you use lead? No, I had to say plumbum boxes. Lead.
Lead, yeah. Yeah, but the lead box would shield from the radiation, from the background radiation around us, but you don't have the uniform field around the sensor.
Yeah,
like a uniform in all directions.
The guys from this radio code, people that building some different people, they are just users. They use little lead balls, and they create boxes of different geometry, and put these lead balls in them. I understand that it's not for this for your purpose, but maybe the idea was good, not to
that's actually
okay, not to melt the lead, but to use this small balls.
Well, that's basically a shotgun.
Yes, it's a shotgun. Yes, this they take it from the shotguns.
Yeah.
But
create on the 3D printer the cases in which they can put this shotgun balls and create some different spheres of various types.
That's actually, well, I mean, for shielding, that's a great idea. That's an idea.
Yes, I believe that that's the best I saw.
You got me thinking about that. Is if the idea is to create a uniform field, could I not use, like if you can buy these little discs, right? It's like 1 microcurie and or 0.1 microcurie and so on from suppliers, different isotopes, CS-137 and cobalt-60, whatever. And so if you want the idea of creating a uniform field, if you can have, let's say in my box, six of them. Yeah, that would be a lot simpler.
Yeah.
And to calibrate it.
Yeah. It's a good idea.
Now the question is, so okay, and use Matvei's idea of the shotgun pellets
and around it.
Yeah. Yes.
But
well, that's a lot more practical than granite slabs.
Yeah, I think so.
I mean, but still, it's easier to carry.
It depends on what kind of material you use. I mean, what kind of source, if it's alpha, beta, or gamma. So, but if
Yes.
they're all the same, then it should theoretically be fine.
Yes, yes.
But if it's too far away with the alpha, you will not have a universal field. Beta would be good. Beta or gamma. But you don't want to have too much gamma around you.
No. No. Yeah, we'll just keep that in the box.
Yes, I think so.
Yeah. Okay, well, there's some suppliers
hold
around.
Second. So hold a second.
Yep.
We have 30 seconds left.
Oh, I see.
Other things?
Michael, did you have anything for us?
Anyway, 7 seconds. So say bye-bye.
Okay. Have a good week, everybody.
Have a good
Good.
weekend.